All right, this video is going to be an explanation on how to create your engineering sketch for your puzzle cube. So to create your engineering sketch, you are going to create what's called an orthographic projection for each puzzle piece. So typically you do this on the same sheet, the orthographic projection, and each part has an orthographic projection. Well, what is orthographic projection? It's how we lay out a 3D part in 2D. We're able to give dimensions and details that we can't really give in 3D, because if I am someone who's making a part from an engineer or design team, typically I don't really have access to the 3D model because I might not always have a computer if I'm in a factory or I'm designing this on specialized tools. So it's our job to create the orthographic projection in the engineering drawing to give to the people who make our parts. So let's look at how we do that. So I'm going to look at this part. This will be our first example. And typically you have to designate the front view. So you look around your part and you pick the part side that has the most going on. So I'm looking around, the bottom looks kind of plain, so do the sides. Clearly the view that has the most going on is this one. So we call this the front view now. So what you do when you get your front view is that you sketch it. And I'm going to click this button on Tinkercad to make it extremely flat, so it looks exactly flat. So it's important to know that orthographic projection is completely flat. So this is what it would look like in 2D here. So let's kind of build this. I'm going to draw it on the computer. You would sketch it by hand. It's just easier for me to do this on the computer because, I'm doing a screencast on Tinkercad and it would be a whole thing. So I'm going to draw this on the computer. So on your paper, you would draw out your front view. So I'll draw it as best I can on the computer. So your sketch on the paper would look exactly the same as this. You should use a ruler when you do this. It's really good to be detailed. And you want yours to look as real to the current object as possible. You don't have to draw this at any specific size for our purposes, as long as it's symmetrical. So you can see here, this translates to this, okay? Sizing doesn't matter. Again, you can fit it on your paper, that's okay. The front view typically goes in the bottom corner of your paper, on the bottom left-hand corner, and you'll see why in a minute. So in orthographic projection, we look at the front, and we've just told whoever's making this, hey, this is what the front looks like. Now, I also need to see the other parts of this so that I can understand how to build this. So typically we do the front view, and then we do what's called the top view. And all views are based off of the front. So if I pick this as my front view, the top view is looking on top of it. So I'm going to click like that. This is what my top view looks like. So again, I would come over here, and the top view goes on top of the front view. And I want you to notice something. I've made sure to align the edges of my views. They line up perfectly. And that's really important in this drawing. They must line up perfectly. So let me just make sure I can actually bring it down to C. On paper, I know you can't do that, but so there we go. So the front view, the top view, and then we use our best judgment. Typically, we also give a right side view, but that may change. So I'm going to see if I even need that. And it looks like I do, because I want to see all the stuff that's going on here. So the right side view looks like this, okay? So it kind of just looks like this flipped around, so I'm just going to move it like that. Okay, so this is part of the engineering drawing. This is the orthographic projection pretty much done. We also include up here a 3D view of the object. So this is where the 3D view goes here. I'm not really going to draw that and put that in right now because it would take too much time. So this is the projection. I also can include a bottom view if I needed. whatever I need. So it's dependent on you, the designer. So let's just say, let me give you an example of why we might use a bottom view, for instance, or another view. So let's say there was a hole in the bottom of this. So I'm going to put a hole in there. Actually, let's do a hole in the side. So let me rotate this. Bring it up. And we're going to bring it through. Okay. So let's say there was a hole. Okay. So let's look at the engineering drawing. I have the front. I have the top. I have the right. At no point in these views can you see the hole that's going through here. So that would be when we need to use a left side view, perhaps. So I'll just take this. Again, you're doing it on paper, so you just be drawing it. I can go there, that's okay. And then I would represent my hole in there. Kind of like that. Okay. That's like I accidentally did a square hole, that's fine. So now, as the person who's making this, I know that there's a little hole in the side here, and it only goes through here because when I'm looking at the right side view, I don't see it there. Okay? So that's the kind of things that you need to look out for, special little features that you need to see and that the person designing or building this would need to know about. In other words, I should be able to design and build this part from this drawing. Now you may be saying to yourself, if you need to build it, you need to know the measurements. So for this part, let me get rid of the hole here. We're going to use a scale of 1 box here equals 1 inch. So if we're using common sense here, if I go 1, 2, 3, this part is 3 inches here. So let's go like this. Let's type the 3. I'm going to make that a little bigger. One sec. So that's going to be 3 inches. Okay. Now, typically how we do this is called a dimension. And what we do here is we use lines that looks like this. So this from here, pardon my crooked lines because I'm drawing on the computer, from here to here is 3 inches. So we put 2 lines and then you just do a line towards it, towards your number. So now we can clearly say that from here to here is 3 inches. So I know that if I were to 3D model this or make it, I have to make it 3 inches. Well, let's put the same here. This is 3 tall. So I'm going to put 3. I'll just draw the number 2. 3. Like that. Okay. Let's look around my drawing and see what else I need here. Well, if I'm looking at the right side, I know that this is 1 inch only because this is 1 box. So we do 1. Okay. And, it's really up to you. You're trying to make this as clear as possible. So if I have these 2 numbers here, let's take a look. So if I wanted to put in this dimension from here to here, we know this number would be 3, okay? But I don't think I really need that because look at this lines up with this, and I have the height here, so we really don't need that there. So I'm going to go ahead and delete that. That's kind of repetitive, and we hate to be repetitive in engineering drawings. You want to make it as clear as possible. Same thing here. I don't need the dimension from here to here because this is done down there, right? It's already there. So I don't need that. If I were doing this drawing, I would put in probably this number from here to here. I'd put it 1. Okay. So that's pointing from this edge to this edge. Okay. So let's see. Now this top, the only thing I want on the top, and I'm going to go back to the Tinkercad model, I'm going to put in the depth here. I'm going to put in 1 right there. okay? And that's pretty much it, I think. You know, if there was a hole here, I deleted the hole. You would put in, you know, a number. We use a diameter symbol, like a diameter, you know, 0.2, or whatever that circle would be. And if there's a circle there also, you would need to locate it, right? You would do the same thing. Put a number here. You know, this would be a number, you know, from there to the center right there. Okay. So dimensions always go on the outside of a part, not like I did there. That was just a demonstration. But they don't, you know, you don't want to start putting dimensions like this. You don't want to go like this. 1 and put it right in the center of your part. That's a little sloppy. You don't want to put, you know, confusing dimensions. Like you don't want to do, you know, from here to here and then go like through the other one, which would be 3. You know, you don't want to run into other objects going like here to, you know, try to avoid all of that. We put them between views so it looks nice. Okay. So you do one of these for each part. So, you know, this is one, you would go on to this one and do a projection drawing. And you could do it on the same paper if you're sketching. So like this one is just this, so it's easier for me on the computer. So I would start my next projection. I'm going to make this the front view. And this one is a weird one because if I look at the front and right, they're the same thing, right? So that's easy. Front and right, same thing. And then the top view is just one singular square like that. Pull it up. There we go. I have my front, my top, my right view. I'd put a 3D view here if I was sketching it. And then I repeat the process. I dimension it, and then I do the other projections, okay? This is a crucial step in the engineering design process, and it's vital that you understand this. If you have any questions, please, please, please ask me.